Spectrum scarcity has been discussed, on and off for the last 15 to 20 years, but right now it really feels like we're really living spectrum scarcity.
There is a spectrum crunch, and I think the spectrum crunch this year is different than the spectrum crunch a decade ago. Now when we look 4G to 5G, what we see is that spectrum and 5G isn't just a matter of better phones. It's probably going to be the engine for innovation in the next 10 years.
It's obvious that our wireless future is reliant upon the ability to share spectrum. What's really unique about DARPA, though, is that our mission isn't to figure out what the art of the possible is now. Our mission is really to ask what's next. And that really speaks to the Spectrum Collaboration Challenge. Using AI to maneuver in the spectrum, using ensemble autonomy and collaboration to make multiple dissimilar types of radio technology share the spectrum at once. This isn't the way the wireless world works today, but at DARPA, our job is to question, well, why not? And could it be possible? And that's really what the Spectrum Collaboration Challenge is all about.
Demands for spectrum are going to continue to increase on both the military and the civilian side. And this is driven, of course, by a lot of the technological advances we're seeing, things like 5G that are going to bring even more opportunities for advances, for services. And the military and the civilian world both want to take advantage of those capabilities. So we're going to be wanting more and more spectrum, and the worlds are colliding. So we've got to address spectrum allocation in a different way, fundamentally different way than what we're doing today.
As the need for wireless spectrum has exponentially increased, it's really thrust together the commercial world and the military world because there is only so much. And so now we find ourselves in a position where we can't be disjoint anymore. We have to share it. And that really makes spectrum sharing technology so important for the Department of Defense and so important for DARPA.
We wouldn't have this kind of event for a standard program. And so I think just the dialogue that's happening because of SC2, that's really getting people to think about dynamic spectrum access, it's something that people know is coming. But I think having this sort of public presence is really sort of accelerating the conversations, the dialogue, and I really hope actually accelerates action and actually change in the way that we manage spectrum, both for the DoD and for commercial systems.
If we continue on our current course, we're going to have problems powering our wireless future. But if we can find new ways to be creative with spectrum policy, I think we're going to see a lot more innovation in the days ahead.
I'm so excited to see all the teams compete, and at Qualcomm we're a huge innovator in spectrum sharing and dynamic resource allocation, so it's pretty exciting to see these algorithms get tested here in this huge competition.
Please welcome former host of TV's Mythbusters, Grant Imahara.
And welcome to the Spectrum Collaboration Challenge Championship event. These teams will witness the culmination of years of hard work as their autonomous radio designs compete in a virtual arena created by DARPA for a $2 million grand prize.
We started this as a competition because we thought that this would really open up the possibility of different types of artificial intelligence that approach this problem. If DARPA were to have run this as a more traditional program, honestly, I think there's approaches that we would have turned our nose up at least at the start. So some of our teams are tackling this as a mathematical optimization problem. Some are using good old-fashioned expert systems. Some are trying their hands at applying modern machine learning and reinforcement learning approaches. The competition that's about to take place right here will ultimately tell us which of these types of approaches will carry us forward into that next generation of wireless, Grant. The final 10 teams in the Spectrum Collaboration Challenge had to have the intersection of computer programming skills, software-defined radio skills. They have to know how wireless communications and digital signal processing works. And of course, they have to have some AI expertise. And to boot, you don't get to the final 10 without deep dedication, sleepless nights, excitement waking up every day to make your radio just a little bit better than everyone else's. And all 10 of those teams had it.
To me, this is a channel simulator, and it's a general purpose tool of high complexity that almost nobody else could have put together except DARPA. I've thought about what it would take to do something like this, and it's really exciting to see somebody already doing it.
It was 4 years ago. We're thinking up this competition. We needed a way to have tens of dozens of radios, all of different kinds, interacting, moving through time and frequency, and of course space, in a multitude of environments. Oh, and it all has to be repeatable, of course. So We really quickly saw that trying to put actual hardware, that is radios, out into the real world, outdoors, was just never going to work logistically. But we realized that with enough computational power, we could actually build an arena, a battleground, that would make our competitors' radios appear as if they were in the real world. But to do it, our arena would have to be the world's largest wireless emulator.
I'm inside the Coliseum enclosure. It's pretty loud in here. The roaring sound you hear is the cooling equipment for over 3,000 tera operations per second of computation and over 52 terabytes per second of streaming data. In order to see just how big this machine is, I need to take you outside the enclosure. In fact, it's so big, you can't see the whole thing from ground level. You have to look from the catwalk to see just how big Coliseum is.
Coliseum, at 256 by 256 channels, is a very big channel emulator. But what's really new about it is not just its size. What's really new about Coliseum is the ability to use it remotely as a shared test resource. This is a game changer.
And for today's competition, we picked Coliseum up from its moorings back in DC, and we rebuilt it here on the LA Convention Center floor.
So before we dive into our first match, I'd like to take a couple minutes to acquaint everyone with the visualization tool that was custom built by DARPA specifically for this competition. Now this allows us to really not only analyze these matches, but actually understand what's happening. And it's worth noting that this kind of thing is really only possible because of the technology that was created for SC2, like Coliseum.
The fact that we were going to build a Coliseum, crazy. The fact that we were going to put AI into radios and allow them to make decisions, crazy. The fact that we were going to give these radios a collaborative lifeline to allow them to interact, never heard of, never been done before. But the craziest thing that we said was we're going to turn Spectrum into a spectator sport.
Without further ado, let's meet our teams.
As all the teams came in, it was a lot of smiles, a lot of excitement. 3 hard years of work, and this is sort of finally their time in the sun. I think GatorWings wins the most innovative intro for the Gator Chomp that they gave us all on the way in. Clearly, I think almost relief to finally be at the finale after that 3 hard years of work from those teams.
The SC2 championship event is comprised of 2 parts, a round robin elimination and a live head-to-head finale. We start the competition off with our 10 teams in round 1.
All right, Grant, now we should also tell the audience here that in each of these rounds, we will introduce a new scenario, with each scenario testing our teams against 5 distinct criteria that are required for successfully demonstrating their collaborative intelligent radio networks can indeed thrive in this world that we've created without the FCC.
We're calling this match Saving Private Scatter.
So this is actually the hardest zone because Scatter has to contend with both the interference from the north as well as the interference from the south.
Once again, let's check out Zylinium clearly going into Hulk mode here, right, in the middle of this. Right off the bat, right, you can see how the spectrum changes as they fly over the ground crews.
This is incredibly impressive that they're able to navigate and get that high priority traffic delivered.
Almost 340% spectrum occupancy.
First 5 elimination rounds of the tournament are designed to take us from 10 teams down to our final 5. And every round ends with sort of a nail biter where the 2 lowest ranking teams go head to head in a knockout. And there's a huge amount at stake here. One of those teams, of course, gets to fight on into the next round of competition, and the other team is out, and that's the end of years of hard work for them.
Tension is very high here. While the lower scoring team will be eliminated, and their journey in this competition will come to an end.
Scatter and Andersons are duking it out over which one of them will be going to the dreaded elimination.
This is shaping up to be a battle between dark horse competitors.
You guys had a very altruistic approach, but unfortunately not able to be successful here today. We've got the final 5 set, let's go. As we enter that final round, you can see on the competitors' faces all at once a sigh of relief. You made the top cut, you made the final 5. And then immediately maybe the sense of realization that now you have to fight it out for that $2 million prize. And you could go home with $2 million grand prize, or you could go home with nothing. And in a matter of minutes, you're going to know that outcome. So really living on both ends of the emotional spectrum there.
We're down to our final 5 teams. Andersons, Erebus, GatorWings, MarmotE, and Zylinium.
I think I could describe the final round in one word, and that's nerves. Nervousness for the competitors. The final round is live. I have no idea what's about to happen on screen.
Now remember, this round is happening live from the Coliseum here at Mobile World Congress.
Ping-ponging back and forth between just sheer nervousness and then excitement when you see, a team leap ahead. That final round was as exciting as you could possibly imagine the Spectrum ever being. We're going to move the finalists back to the slice of life scenario. This time, we're going to make it a little more challenging for them. They now have to contend with a legacy radio system. For the teams to successfully earn points here, they'll need to learn on the fly how to manage their aggregate interference to this incumbent. Yeah, it looks, Ben, to me like they're trying to slowly learn what that passive incumbent can tolerate and what it can't. We see they've broken its threshold again, but they've all dropped down in power. And now they're raising that power back up that the threshold comes back up. So we're seeing them start to adapt.
Now, I see GatorWings actually trying to put most of their energy in that band where there is no incumbent. MarmotE, Zylinium, and GatorWings looks like they're in a dead heat right now for first place, and they're not stopping.
Andersons is gingerly adding additional wireless applications to their flows. Unfortunately, I think that's left them at the bottom of the pack, Ben.
GatorWings has just eked out Zylinium and MarmotE for first place, and they're still moving quick for that finish line.
Ben, we've got over 2 minutes since we last tripped that incumbent's threshold. These teams have really figured out how to protect that passive incumbent.
Yeah, I think they've learned how to avoid it and how to co-occupy Spectrum with it. GatorWings starting to put a gap between them and Zylinium. I think they're going to hit it.
Whoa! All right, GatorWings.
Let's review the leaderboard standings. Match 1 point so far. GatorWings with 10, Zylinium with 8, MarmotE 7, Erebus 6, and Andersons 5.
Now in this match, again, we'll see our teams show down in the alleys of Austin. But this time, there's a twist. We're going to see how well our SC2 radios can stack up against LTE. If any of our competitors reach that finish line before the 3-minute mark, we will have witnessed that team outperforming LTE while collaboratively sharing Spectrum, Ben.
Okay.
All right, all teams starting to drop applications down and score points right off the bat. And there we go, Zylinium, last man over the line. Zylinium actually the one struggling in this particular match. We're looking to see a team hit that point value before the 3-minute mark.
MarmotE making a breakaway, Paul. MarmotE might actually hit the
by
finish
themselves,
line.
Ben.
I think they're going to do it. They already
300.
They crushed it. They hit that about halfway through stage 2.
Wow, Ben, they really put the pedal to the metal there. Grant, we've got ties at the bottom, and we've got only a point separating our top 2 teams. There's 2 matches left, still anybody's game. Now it's time to revisit the trash compactor. For our final round, to make things fair, we've taken all of our teams and we've evenly distributed them across the 5 alleys. All right, Ben, right out of the gate, we've got all the teams making huge application deliveries.
Bonus.
Ben, we're down to the final 5. We expect the best out of the final 5 here. And
okay, we see teams accelerating in points.
Point values are double. Teams are going to accelerate towards that bonus line here, Ben.
MarmotE, GatorWings, and Andersons all moving up quickly.
MarmotE is steadily pulling ahead of the pack, but GatorWings and Andersons nipping at their heels, Ben.
Paul, Zylinium is racing to catch up to Erebus here.
MarmotE scoring about 30 points more every second.
They just stopped as they crossed into stage 3.
Last stage here. Point values tripled.
Whoa,
and it's a tear.
Anderson's just breeding GatorWings for second.
Whoa, MarmotE!
MarmotE with 27, GatorWings 25, Andersons 20, Zylinium 19, and Erebus at 17.
All right, so we've got really tight races here for our 4th and final match. Here, we're going to revisit Wildfire. Now, in this version, we've made it equal across all teams. That is, each team has an equal opportunity to score high priority points. This is anyone's game still at this point.
Oh, there we go.
My goodness, we've got GatorWings pulling well ahead of the pack. Zylinium and MarmotE just can't catch up to their point totals, Ben. For Ben and I, trying to call those final 4 matches, right? We haven't spent a week diving into those matches to figure out what's happening. I mean, we're seeing it live in front of us. And so, like any good live sports commentary, Ben talks and then I see something and then I jump on top of Ben. You know, there's a little bit of auditory chaos, but I think it represents the real excitement that Ben and I both felt, as well as I think the rest of the audience was feeling, you know, watching those teams sprint towards those finish lines.
GatorWings, though, putting the pedal to the metal. Yeah, okay, we've got 2 priority flows now from Anderson's. Oh, and there goes Zylinium displacing GatorWings.
GatorWings. There's not a lot of distance between GatorWings and the finish line, Paul.
All right, and here we have the winning teams.
Coming into the final round, right, we had MarmotE, GatorWings, and then Anderson's. But the scores were also close that it was still anyone's game at that point. And so then we played the final match, and then of course looking at the reveal of the leaderboard, huge shakeups. Anderson's now suddenly going home with no prize, Zylinium able to claw their way up into that 3rd place spot, and of course GatorWings managing to score enough points and displace MarmotE from their lead.
Oh, we are very excited but deflated at the same time. We just lost and won $1 million at the same moment.
It feels really great to be here right now. Somehow we won the whole thing, so won the DARPA Spectrum Challenge after 3 years of hard work.
Yeah, so it was a roller coaster of emotions. We ended up in 3rd place. It's stressful, but we're just glad that we're coming out of here with a prize, and glad that the last 3 years of our lives have, you know, come to this. So we're excited.
Folks, today we've witnessed the dawn of a new frontier in wireless. For the first time, we've seen AI-enabled radios collaborating autonomously, unlocking the true potential of the RF spectrum.
I think when you try and take stock of what we witnessed at the championship event, you kind of have to hold it in 2 categories. There's immediately what did we witness, right? And I think in that category, we saw teams not only outperform the status quo of static spectrum allocation, but we saw teams also excel over a wireless technology standard that we already all know and have in our pockets, LTE. I think what we saw the teams achieve is the fledgling proof of a completely new wireless paradigm, one that I think will take years to pay off. But I think if we check back in on the spectrum 10 years from now, we're going to see the mark that this competition has left on how wireless works. We build the competition as using AI to unlock the true potential of the spectrum. I think we saw that. I think we saw this idea, you know, albeit in a microcosm, right? We took, you know, 10, 20, 40 megahertz of spectrum and said, this is your playground. You don't have carte blanche to the entire wireless world. You live in this small playground. You get the most out of it you can. And I think, you know, in more than one occasion, we saw 200% spectrum use, 300% spectrum use, 350% spectrum use. So I think we saw that we can use AI and dynamic decision making and collaboration to unlock the true potential of the RF spectrum.
One of the best examples was when they put the LTE current state, what we're capable of doing, and watching each of the teams not only, you know, move past it, but accelerate way past it.
Well, I just saw an amazing event. To be honest, what I feel like I just saw was the future. I think it's the first time I actually saw that the autonomous decision making is better than what a human would be able to do. Even a human, given a lot of time and a lot of thought, can do fairly well, but I think we just saw in real time, or at least in seconds, right, that the computers and the AI were able to actually outpace what the human would be able to do.
So I was counting, I think this might be the 10th challenge that DARPA has had since 2004. What's different about this one is the collaborative part, the C part.
Collaboration paid off in the competition in exactly the way that we thought it would. And the key here is that artificial intelligence needs feedback in order to learn what works and what doesn't work. You can either infer that feedback or guess, or someone can tell you. And the more uncertainty you have in your decision making, the less sophisticated your decisions are, the less efficient your decisions are. And so we believed at the onset that this idea of collaboration, that sharing information, was key to sort of reduce that uncertainty so that the radios could make better decisions. So collaboration ended up having exactly the role at the end that we thought it would at the beginning.
I think we had a moment maybe midway through the third phase where we really started using the collaboration data more. And once we started doing that, we saw huge performance improvements.
The teams actually built the collaboration language that we saw in the championship event. Now, DARPA acted almost as a moderator, you could think of it, but the ideas, what information would be shared, how would it be shared, how often does it need to be shared, all of those concepts actually came from the teams themselves, and we developed a process of voting and ratification so that everyone had a voice. At the end of the day, the teams own the collaboration language. It really is a product of their hard work, and I think it shows, and it paid off in how their radios ultimately performed.
So it turned out that we not just built the SEAL language, but along the way we really build some relationships, personal relationships or professional relationships among the teams. So yes, we love these guys. We need to figure it out, the exact framework, how we can work together with them. Yeah.
Over the course of the 3-year competition, there's been a quantum leap in the ability of these radio networks to effectively collaborate with each other.
What's next for the teams technologically? It's really twofold. We've seen this technology thrive in Coliseum, this test bed we built for the teams so that you could sit remotely from the internet and conduct very large-scale experiments and really ameliorate all the logistical hurdles of doing that. I think now is time to introduce the logistical hurdles. We've seen it successful in Coliseum, now we want to see it successful out in the real world. The other step that the teams really have to take now is to figure out how to apply the technology they've built, not to the wireless world that DARPA has dreamed of that's years in the future, but how to apply it to the wireless world today. And that means that we're going to have to take the decision engines, the AI, out of our Spectrum Collaboration Challenge radio networks, and we're going to need to hybridize that with existing standards, Wi-Fi 6, 5G new radio, and a litany of others that are all really ripe to have innovation in the form of AI in how they use and optimize the spectrum. Competition is never about the state of the technology. When you snap that line, when you reveal that final leaderboard, the competition is about showing that there was a very different way to do business. I think we did that, and in doing so, we also, I think, discovered all of the challenges that lay in front of us to take this technology from where it exists at the end of the competition to actually, having it in your cell phone.
So winning third place in SC2 has validated all the work we've put into it, and it's also validated the technology. So we're pretty confident we can turn it into a product and deploy it out in the field.
A really important byproduct of a competition like this isn't just the technology, it's not the final event, it's really the community that is created at the end. We've created a strong community that embraces AI, wireless, this idea of collaboration. Now's the time for entrepreneurship. Now's the time that these teams are going to start to take these ideas and bring them out of the SC2 competition fold and bring them out to the real world and start to bring them into new as well as existing wireless technologies.
But now that we can talk to the other teams, maybe we can build something more upon this nice foundation and do some more collaboration.
Honestly, we're thrilled to collaborate more with the other teams.
Well, first of all, we want to know what they have been doing.
What were they doing?
Yeah.
Yes. There's a lot, so we can only see from our little window, from our perspective. Yeah. So yes, we would love to know what some of the other teams were doing and try to work with them on building better radios.
Today, we challenged these teams, but we saw them able to provide us stable service in spite of sharing spectrum. We saw their ability to reuse spectrum. We saw their ability to dynamically prioritize. We saw them handling surges, and we saw them operating in congested environments. And then we threw one more thing at them, and we saw their ability to protect an incumbent.
I think the next step for the teams is a probably well-deserved vacation. I imagine a lot of very angry spouses. I'm probably a picture on a voodoo doll somewhere that's being, tortured for years and now can be put aside in a closet.
Feels great. We feel justified. All the hard hours we've put in have been really, tiring and exhausting, and just being able to take everything that we know about wireless communications and artificial intelligence and put it to work and show that it can really perform, it's been fantastic.
Our competitors packed 3.5 times more wireless signals into the spectrum than we're capable of today. Our teams outperformed static allocations and demonstrated greater performance than current wireless standards like LTE. The paradigm of collaborative AI in wireless is here to stay and will propel us from spectrum scarcity to spectrum abundance.